Hello, my name is Fernanda Sobral and today I'm going to solve the quiz number 1 from week 2 from Physics 2. So this quiz says, it's in Spanish. Una esfera hueca de 8 centímetros de radio interior y 9 centímetros de radio exterior flota sumergida a la mitad de un líquido con densidad de 800 kilogramos por metro cúbico. ¿Cuál es la masa de la esfera? Esa es la parte A. ¿Y cuál es la densidad de la esfera? Esa es la parte B. Okay, so back to English. I drew here a small diagram that shows what the problem says, which is that there is a sphere that is hollow and it has an inner radius of 8 and an outer radius of 9. So first it asks for the mass of the sphere. So what I'm going to use is the formula that says that the buoyant force should equal the mass of the sphere times gravity. And we know that this buoyant force can be obtained also as the density of the fluid times the volume of the fluid displaced times gravity. So we're going to use that to calculate the buoyant force, and then we are going to take out the mass of the sphere, and that is going to give us a result. So the buoyant force should therefore equal, as I said before, first of all, the density of the fluid in which the object is placed, and then the volume displaced. So the volume displaced should be half the volume of the sphere, because the sphere is placed to like the half of half of the body is inside the fluid. So we are going to take as the volume, we're going to use to calculate the volume the outer radius, because that is the volume that will be displaced. So we know that the volume of a sphere I don't know what I wrote. Yes, is equal to 4/3 of pi times the radius to the third. So this is a volume we are going to use, and then we can multiply it times gravity. So we have the density times the volume, and this divided by 2 because it's only half of the sphere inside under the water. So we have the density times the volume of the sphere. This is in meters because this is in kilogram per, this is cubic meter, times the gravity, which is 9.81, and this gives us a result of 11.98 newtons. So then we can use this to know what is the mass of the sphere. We know that the mass of the sphere should be equal to the buoyant force divided by gravity. Therefore, it should be equal to 11.98 divided by 9.81, which should equal 1.22 kilograms. And that is part A of our problem. The second part of the problem asks for the density of the sphere. So we know that density is defined as mass over volume. We know that the mass of the sphere equals 22 kilograms because we just calculated that. So we have to calculate the volume and use the standard formula to know it. So in this case, the volume of the sphere, as it takes only into consideration like how packed is the mass together, should be what is here. Like assuming that it is completely empty on the inside. So this volume can be obtained by subtracting the volume taking into consideration the outer radius minus the volume taking into consideration the inner radius. So it should be equal to 4/3 of pi times 0.09 to the third minus 0.08 meters to the third, which are the outer and inner radius. and this is finally equal to 0.0009089.7 cubic meters. So then we can just calculate the density. The density of the sphere should equal its mass divided by its volume, which equals 1.22 kilograms divided by 9.0897 times 10 to the minus 4 cubic meters. And this should be equal to our final result, which is 1,000 and, well, it is approximately 1,342, but we're going to leave it as this because of the number of significant figures we have on our initial data, which are 2. So we're going to leave it like this. It's approximately this value in kilograms per cubic meter, which is the units we're using for density from the beginning of the problem. So that's all. Thank you.